welcome to our subject manufacturing processes 2. Now, we are going through module number 7, the manufacturing of screw threads and gears. Today's lecture number 7.1 will be production of screw threads by machining, rolling and grinding. Of course, the threads are produced by different methods, but mostly by machining, rolling and grinding. Now, what is the content of the lecture today? Identification of the general application of various screw threads. Before we go into manufacture of screw threads, we must understand what are screw threads, what are the application of these screw threads, what are the different types of screw threads, and what are the wide spectrum of manufacturing methods of screw threads, and then general methods with more description. So, first is identification of the general application of various screw threads. Second, classify the different types of screw threads. Next, state the possible methods of producing screw threads and their characteristics. And finally, we should visualize and describe the various methods of producing screw threads by machining, rolling and grinding. Now, let us start with general applications of screw threads. Screw threaded objects like nuts, bolts, studs, screws of various type and size are widely used in engineering and day-to-day life. Everywhere you will find screws or threads or nuts. The general uses of screw threads are very large, but basically for fastening by screws, bolts, studs. Suppose two plates have to be joined temporarily. So, some hole has to be made, and through the hole say number of bolts and nuts will be there for tightening, and when required you can unscrew it and dismantle. So, this is called temporary fastening. So, screws, bolts, studs, these are used for fastening one part with the other. Joining. Now, the two joining, we say for example, two rods have to be joined coaxially. Two pipes have to be joined coaxially. For example, say there is a rod and there is another rod to be joined. We can join in various ways by welding, that is permanent, temporarily by threads and so on. And it can be pipes also. So, there will be threads on the pipes and then you can join by another small piece, threaded piece. This is also temporary. Now, clamping, holding something in a space strongly, so that it does not move under action of the forces and all this. So, this is done say for example, C clamps. By a C clamp we tighten this jobs on a clamp, or we keep the objects say jobs or blanks in machine tool in vices. Say in drilling machine, in milling machine, in grinding machine we use different types of vices, and many of the vices are operated by strong screws. Then jaws of chucks. Jobs are held in chuck, say self-centering chuck or say four independent jaw chuck, but there are the jobs are held by the jaws, and the jobs have got partial threads, and these threads are used to move and hold the job. Another application, control linear motion of slides. Say the cross slide. The cross slide of a lathe is moved by a screw. The compound slide, that is also made to move by a screw. The quill of or the barrel of say tailstock, that is also operated by a screw. Then the tables of milling machines, tables of sometimes say grinding machines and other drilling machines are made to move by screws, okay, or lead screws. Transmission of motion and power. For example, the lead screws of lathe. So, lathe has got a lead screw. What does it do? It converts rotation into rotation from the motor or from the spindle into translation of the saddle. So, the power and motion are transmitted to the tool from the job or from the motor with the help of a lead screw. Continuation, converting rotary motion to translation. Suppose you want to convert rotary motion into translation. best example is says screw and nut. You rotate the screw and the nut will travel linearly. Position control in instruments. Suppose an object is put on a table, a small table of a microscope, and it has to be shifted either x or y direction, and those are accomplished by screws or threads, lead screws. Precision measurement of length, say micrometer. In a micrometer there is a spindle, threaded spindle, and when you rotate this spindle or thimble, then this gap between the anvil and the spindle changes, and we can measure the length of the or thickness of the job. Acting as worm. Now, what is screw thread? Thread and worm are same. What is worm? Worm is a single tooth gear which looks like a screw. So, if worm is a screw, then screw is also a worm. So, screw can be used sometime for transmission of rotation from screw to the gear, or just like the worm to worm wheel, and there will be huge reduction. High speed will be converted into low speed reduction, just like worm, but this is not very widely used. Exerting heavy forces. Now, sometimes we need applying heavy force to compress or press certain things. So, in heavy press, hydraulic press, there are the mechanical presses where the heavy things, say a blanket or a clothes, those are to be pressed, or other materials by screws, and those screws have got strong threads. Conveying and squeezing materials, screw conveyor. You are familiar with screw conveyor? So, it is also behaving like a screw or threaded object which is used to transport materials, say removal of chips from the lathe by screw conveyor. Screw pump, there are also screws used for pumping oil. Injection molding machine, in injection molding machine the plastic granules are moved forward and then pressed and squeezed by a screw. Automatic feeding. So, in automatic assembly, say bearing or some other pieces, some small minute parts, identical parts have to be continuously fed into the assembly very quickly, and that can be done by screw. All right. You can see books how it is done. Next is classification of screw threads. Mind that screw threads may be of different type. It is not as simple. There may be various types and with various applications. There is a wide range of threads in size and shape, in configuration, in application, and so on. Now you can see screw threads can be classified in various aspects. In different respects they are different. Location, for example, external thread, or just like screw, bolt, stud, there we have got external thread. Here there is a bolt, so this has got external thread. If there is a nut, then this will have internal thread. So, according to location, threads may be external, threads may be internal. Next is configuration. This configuration really implies the thread can be straight, the bolt can be straight, it can be tapered like that, or it can be radial, Archimedean spiral type, radial type of thread. Now, what is the example? Most of the nut, bolts, etc. lead screws are straight. So, the threads are cut on a cylinder, and cylinder is a straight cylinder with continuous diameter. Now, the taper thread, threads are cut on the taper body. For example, in the jaws of drill chuck, they are called taper threads. There are taper threads. On the spindle, there is a nut in micrometer that has got some taper thread. So, taper threads are also used for fixing pipes to make it the junction leak proof. There should not be leakage of gas or fluid. For that, some taper fitting is there that gives very strong fit, airtight. Radial, for example, radial or scroll type, that is a self-centering chuck. Thread form. Now, there are different types of threads. Sometimes the threads are sometimes V type, sometimes square type, sometimes acme type, it can be buttress type. Like now, V type most common, it can be either 55 degree BSW, British standard, or it can be 60 degree say international standard or American standard. This V thread, this angle may be 60 degree. Acme thread, this is a trapezium type and the angle is 29 degree. This kind of threads are very strong, used in worm and other lead screws, heavy lead screws and so on. Square threads for is very strong, this is for press where heavy forces are to be transmitted. Buttress is a 45 degree angle. Then worm is also similar to acme, but the angle here, the angle is either 29 degree, that is double of pressure angle 14.5 or 20 degree pressure angle multiplied by 2, 40. So, in worm thread, the thread of the worm single tooth gear will be 40 degree or 29 degree. And then semicircle, sometimes you know that the threads are circular type, the threads are like this, and so this kind of threads are used for recirculating ball screw, Novikov gear, not Novikov, but in say semicircular group is done for recirculating ball screw type. You know, in all screw nut system, the threads are subjected to sliding. Okay, a lot of friction, rise in temperature, wear and tear take place. But there are modern screws where the contact is through rolling. A set of balls roll in between the threads of the nut and screw. In that case, the grooves of the threads of the nut and bolt both are made semicircular. Now, according to standard, so direction of helix, it can be right handed, it can be left handed. If we put a nut and if it is a clockwise or right handed, then nut will come back or screw will go forward, and if it is left handed, sometime it is left handed, if we rotate the screw, the nut moves forward. Sometimes left hand thread are used, for example, say in the cross slide of lathe, in the tailstock of lathe and so on, but those are costly, difficult to make. Standard BSW was most common, British standard Whitworth. The thread is explained by or specified by inch, the diameter, the gap between the threads and all these things are by inch, BSW. American standard, the international standard, they are called metric thread. Here the space between the threads are called pitch, and this is expressed in millimeter. Now, spacing, size of thread. Now, threads can be very small threads or it can be large threads on the same diameter or on different diameter. Okay. And the spacing can be expressed, say number of threads per inch, that is TPI, number of threads per inch. If large number TPI is large, that means threads are very small, or directly pitch, that is the gap between the threads, that is called pitch, the gap between or the distance between two consecutive threads, pitch in millimeter. Number of start, it can be single start, most of the threads are single start, there will be only one thread continuously moving helically, but there can be multiple start, but 2, 3 or up to 4, so there can be 4 threads. Okay. So, here the lead will be very fast. So, the multiple threads are used for large lead. Now, fineness of threads, most of the threads are general type, but sometimes fine threads are required in pipes for gas proof or water tightening and all these things. They are fine, the thread pitch is very small or TPI is very large. And the segmentation of circle, suppose this is the a thread, okay. This is a nut. Now, this can be half, so you can remove the bottom half. So, this will be called half thread or half nut, or you can make only this small portion useful and remaining part you can remove. So, this can be a full circle type of thread, it can be half nut kind of half thread, or it can be segment, small part segment, but the effect will be more or less same, difference will be in strength. Now, general methods of producing screw threads. There are many methods of making screw threads. You will be surprised to see that casting is also a method. You can produce threads by casting. All right. What are the characteristics? It is made by casting. Is a rare. number of threads may be only 1 or maybe maximum 2, all right, very few threads. Accuracy, no question, very poor, because it is a casting process, and use threads on mouth of glass bottles. You can see there are beverage, glass bottles for cold drinks and all these things, which has got thread at the top, and the cap, the plastic cap or metallic cap, which is also called internal threads, and tightened on these glass bottles. On the glass bottles, the threads are produced by casting. Forming, this is a very common method. Forming, not all method, only rolling. Amongst forming, rolling is the process. Okay. Now, what are the characteristics of rolling if made? Work material has to be ductile material, so it can be formed or alloys. Process, larger threads, if threads are very large with a large depth and width, then they have to be hot rolled, because this will require lot of forces if done in a cold state. Now, if you do it by hot rolling, then accuracy and finish will be poor, so they have to be finished by machining and grinding later on. But smaller threads are directly made by cold rolling process, and no further finishing may be required. Property of the threads produced by rolling. Rolled threaded parts are stronger and tougher, because in machining the threads are cut, material is cut, and lot of stress concentration can develop here and there, but in case of rolling the materials are not cut, they are just formed or deformed or displaced. So, strength and toughness remain. Application of rolled threads, it is very common for small components. Large screws or threads or lead screws are not made by rolling. Rolling is used for small components like screws, bolts, etc., but they are very fast in production, unlike machining. Now, what are the other methods of manufacturing threads? Machining, removal process or machining. Now, what is removal process? Machining process. Machining is the process of removal excess material in the form of chips from the blank with the help of a cutting tool, which will be moved relative to the job surface, and this work will be accomplished in a machine called machine tool. So, it is a continuous removal of excess material slowly in the form of chips, that is called machining, number 1. So, from a cylindrical surface the material will be removed from the groove gradually. Precision, in respect of precision, machining produces wide range of precision, medium to very high. Production, yes, production rate also widely varies. It can be very moderate, it can be medium, it can be large volume or mass production, all right. Now, finishing by grinding. Now, what is the purpose of grinding? Mainly finishing after machining or rolling or heat treatment, because after heat treatment it becomes so hard that rolling and machining cannot do anything, only grinding will serve the purpose. Even after machining or rolling, we do not do treatment. If we do not do treatment, then finishing may be required for their functional requirement, and that will be done. Finishing means dimensional accuracy and surface finish by form accuracy by grinding. But nowadays grinding is a process which is as good as and as productive as machining. So, simultaneously originating the thread and finishing the thread will be done together. So, no machining will be required at all, but this will be applicable for generally small jobs, but for heavy jobs, well, like lead screws, this machining and grinding can be done, finishing can be done simultaneously by grinding. Quality of the thread produced by grinding definitely will be very high in accuracy and surface finish. Application, wide range of type and precision. Now, come to general methods of producing screw threads. So, there are other methods also which I am to tell you that. So, we told about casting, for rolling, machining, grinding. What are the other methods possible? That is precision forming to near net shape. Near net shape means preforming very close to the final dimensions, so that machining is not required, grinding if required may be very small amount. This is called near net shape principle, which is done by say investment casting, injection molding and so on. But this process, in this process also say small internal and external threads can be produced. Non-traditional processes, say micro machining in exotic materials, how will you do it? You have to do it by these non-traditional methods, by electro discharge machining, electrochemical machining, laser machining and similar process will be utilized. Work material has to be difficult to process, which cannot be done by conventional method, and use fine and micro threads, precision threads. So, these are coming up, this non-traditional process. Now, various common methods of producing of threads. Now, we shall discuss in more detail with a diagram as well as a description, but we shall remain confined not to only machining, rolling and grinding. We shall not discuss in detail about the other methods, only these three which are very, very common. 99% threads are produced by these three methods. Okay. Now, let us come to production of screw threads by machining. Let us start with a removal process. Now, again, what is the machining principle? Removal excess material by tool producing helical grooves or threads. So, it is a gradual removal process. There are two basic ways, either do it manually slowly using the hand tool like taps and dies, or you can do it in machines mechanically like machine tools. That will be much faster and accurate. Now, the thread cutting manually using hand tools, rarely or occasionally, you know, sometime these threads are one or two pieces, few pieces are manufactured by say manual process. Now, when we shall do this manual process? We do this manual thread cutting for external as well as internal threads, both of small size, please note, and soft materials, which can be easily done by with a manual force. For few pieces, only one piece or two pieces, maybe three maximum, only for in manual fitting, assembly and repair and maintenance. So, it is not a regular, you know, kind of production of threads manually. You produce one or two pieces as and when required for repair, maintenance in tool room or fitting shop and so on. But what are the processes by which you can do this thread cutting? Let us talk about making external threads like say bolts, screws, studs, etc. There are different types of dies are used, these are called dies. Okay. External threads are produced by die, D-I-E, die. This is the die. Now, this die really this is producing external thread. So, the die tool will look like a nut which has got internal thread. So, internal threads will be utilized to produce external thread. This is a die, this is called solid die, which is basically which looks like a nut, but the material is harder than nut. This is either tool steel or high speed steel, basically tool steel having thread inside, but some axial grooves are cut called gaussing to produce the thread, otherwise it will not act. So, these are called gaussing. This is a solid die, this is a spring die. The gap between this die has to be used only for once. In one rotation the job has to be complete, say in one spell, but if the thread is slightly bigger or harder, you cannot do it manually in one pass. So, you have to use a number of passes. For that, this gap or the hole has to be gradually reduced by tightening the screw, and this slit will help you reduction in diameter. Now, this is called split die, where the die is made in two pieces, one piece is fixed inside, other piece is moved forward by this screw and the gap changes. So, by number of passes you can produce the thread. Of course, it can be used for other purpose also. Suppose you want to make another thread of different TPI or different pitch. So, you change these two pieces, put another pair into this die stock, and then you utilize it and rotate this manually. This is called die stock or handle. Now, for pipes, for cutting the threads and pipes, that is called finer thread, that requires a bigger type of die. These are the special die which is fitted into the handle through a bush, and this is rotated manually to produce the thread in the pipes end. This is called external threads. In pipes and generally external threads are produced. Now, what about internal threads to be produced manually? This is process internal threads by taps. These are called taps. Now, when we cut external thread, we use internal threads. Now, we are going to cut internal threads. Internal threads, we shall use tools having external thread. You see, these are called taps, which basically look like bolts, okay, or screws, but here these are materials are high speed steel or say tool steel, and there are gushing or slots, so that sharp cutting edges are developed. Now, for making a whole tap thread, it has to be done in 3 stages. First, a taper tap has to be put in and rotated and then withdrawn. Then it has to be semi finished by a second tap or plug tap, and finally it is finished by a bottoming tap. So, these 3 taps are used in sequence to get a perfect through threaded hole. Now, sometimes this can be generally when you use tap manually, the job is held horizontally and the tap is held vertically and is rotated horizontally, but it can be done in a machine tool lathe. You hold the job, this is the job and this is the tap, and then this is a die stock, you rotate, this is held in the tailstock center and you rotate this one manually and gradually push it, you get the thread inside the job, but still it is manual. Now, cutting threads in machine tools mechanically, and which will be a little faster and large volume of production and wide range of production and with high accuracy. Now, when you say machine tools, what kind of machine tools usually are used? Lathes are most widely used, and occasionally drilling machine, and for very high production sometimes special purpose thread cutting machine tools are also used. Now, let us discuss with machining threads in lathes. Now, friend, there are different types of lathes. See, according to automation, say non-automatic lathe, mostly central lathe, and then semi-automatic lathes like capstan lathe, turret lathe, and automatic lathe like single spindle automatic, and so on. First, let us discuss the central lathe, which is most commonly used, most widely and commonly employed. Now, again let us start with external threads. How we shall make external threads in central lathes? This can be done in various methods. One is chasing or cutting by single point or multi-point tool, just like turning. Is a single point chasing or multi-point chasing. You see the diagram. This is the rod which was mounted on the headstock supported by tailstock is a rod, and this is a cutting tool which has got a definite thread form 55 degree or 60 degree, and this will have moved in this direction, feed motion. Job will be rotated, and the rotation speed, that is RPM, and the feed motion have to be synchronized such that in one revolution of the job the tool will move by one pitch or what is called one lead. Okay. Now, this is by single point. So, this gives high accuracy, but it is a slow process. This can be used for small size to large size of threads, but problem is productivity is low. Now, this productivity can be increased by having a multi-point chaser which has got say 4 or maybe 6 threads. So, 4 or 6 threads can be done simultaneously. So, this will give slightly higher productivity, but this is chasing. Now, by thread milling, now you see in a lathe we are talking about machining external threads in central lathe, but the operation is milling. Yes, you remember that operations like long thread milling, short thread milling can be done in lathe by attachment, milling attachments. Now, here you can see that this thread, this is the product, okay. This is the product which is where thread has to be produced over a short length, and fine threads have to be produced, and this is the cutting tool. The cutting tool is made of a rod of harder material having annular ribs or grooves. This is not helical, these are not helical, this is straight annular grooves, and the threads are exactly similar to the threads to be obtained. Now, this tool which will be rotating at high speed will be mounted on an attachment, and this attachment will have a motor to drive it, and entire thing will be mounted on the lathe bed. So, not lathe bed, is saddle, and then this will be moved in this direction, this will be slightly moved in this direction, and then the job this will be rotated slowly, the job, and you get the entire thread done over the periphery. Here the production rate is very high, the job has to be rotated by say only 1.5 revolutions, enough, and the amount of movement, radial movement and axial movement of the tool will be also very small, maybe 2-3 pitch only. So, these are high production methods, but used for small threads, small diameter, small pitch, and finer threads, and small length, and so on. But long thread milling, this is long thread milling. When say long screws, very long screws is large threads, either Acme thread or square thread or even V thread have to be manufactured, like lead screw of machine tools, which is very long. How this will be done? This will be done by a milling cutter. So, the single point cutting tool will be replaced by a milling cutter, which will be mounted on the saddle as an attachment, additional attachment, and this will rotate and move in the forward direction, and the job will rotate accordingly in a synchronized fashion, and you get the threads cut. This is called long thread milling. Now, by rotating tool, this is another interesting thing. Now, suppose there is a job, very odd shaped job like this, and the thread has to be, this is odd shaped job, very heavy job and odd shape, and the thread has to be cut only in this region, okay, at one point. Now, this kind of thread has to be done in a lathe. This job has to be mounted on a face plate on a lathe, and this has to be rotated slowly about the axis, okay. But the tool, the cutting tool, here you see the job will rotate in this direction, will rotate in this direction, and the cutting tool will rotate in this direction. So, only this portion it will be in contact with the job and remove a layer of material, but this will come back very quickly at high speed and remove little more material. So, this will gradually remove the material from the groove, and this will continue because this will move axially also. Now, what is the advantage? The tool will remain in contact with the thread for a short while. So, it will get enough time to cool down and look for lubrication. So, for very large threads on odd jobs which have to man hard materials have to be machined by this rotary tool, which is very efficient with better cooling and lubrication. Now, this is external rotation, and here the tool will rotate around the job like this, and this will rotate in a different direction. So, here you produce the thread by removing the material intermittently. This also, these are also used for large threads and odd shaped jobs like castings, like forgings, like that. Now, machining internal threads in center lathes, that is very similar to the previous methods by single or single point tools. So, this is the internal thread, this is the workpiece, hollow workpiece cylinder where internal threads are to cut, and this single point cutting tool, just like boring. Then machine tap, this is a machine tap, this is not tapered, straight, and front portion is tapered, but the rear portion is straight. So, by pushing, rotating and pushing this tap through the job, you get the thread done in lathe. And internal thread milling, yes. Now, we talked about external thread milling, producing jobs on external the body, but if there are rods like jobs and there is a hole and you have to produce threads internally, then you can use this kind of tool. This will be fitted into the say tailstock and or in the saddle or in in the attachment, and this will rotate at high speed. This will be working inside, this will be working inside, and this will rotate high speed, this will rotate at slow speed, and this will move gradually inside, and then you take it out. Now, machining threads in semi-automatic lathes like capstan lathe, turret lathe, okay. you remember the capstan is a smaller low duty and turret lathes are heavy duty, but both of them are semi-automatic and have got a turret with 6 faces to hold 6 cutting tools, and in addition to say few slides, front slide, rear slide and so on. What do you find here? We use self opening die, self opening die. So, this is the hexagonal turret. Suppose this is the hexagonal turret and there will be a self opening die with an handle, and this has got cutting tooth. Now, this is a block like a cylinder and there are chasers, these are called chasers, okay, thread chasers. So, the job will rotate and they will remain in position and the threads will be cut. Now, this will move radially, these chasers will move radially radially. Now, this can be, so when this will move forward, suppose this is the job fitted into the spindle, okay, and thread has to be cut here. So, this will move forward and with a larger opening. So, this it has got, this die has got a larger opening and this will move forward, and then this will move forward with this space small definite amount. So, it cut the thread, and after that, after reaching the end position, the cutting tooth will move out radially, outward radially. So, this will open and then this will be brought back without stopping or reversing the rotation of the job. So, this will save time. Now, this cutting tooth, the cutting tool, they can be radially fed, this can be tangentially fed, and this can also be radially fed, and this is circular type, these are flat type, these two, and this is circular type. So, there are different types of tools, and all these cutting tools are placed inside, and all the cutting tools are moved forward towards the center or around the center simultaneously by manually by this one, and after it reaches the end, it automatically opens because of the force. So, this is self opening die, which is a little faster working than other dies are used for semi automatic lathe for batch production. But how to cut in internal threads in semi automatic lathe, say in turret lathe, by a tap. You remember the internal taps, internal threads are produced manually by say taps, collapsible tap or machine tap, but in this case this tap is called collapsible tap. Now, it goes inside for cutting the thread, it goes inside for cutting the thread. After cutting the thread, all these cutting edges they move radially in by operating this lever. There is a cam which make all these things radial screw cutting pieces radially move inside. So, the diameter becomes smaller and this can be taken out easily without stopping the job or reversing the job. So, this is also much faster working than other kind of dies and taps. Now, machining screw threads in drilling machines. Yes, you remember that in drilling machine, what are the use of the drilling machines? Drilling machines are used for mainly originating hole in solid bodies, but this can also be used for making say counter sinking, counter boring and similar operations, but thread can also be cut, internal threads only. Mind that if you cut thread in drilling machine, they will be mostly external threads, internal threads, only internal threads are cut in drilling machines, not external threads, and this is done by using tapping attachment. So, this is very faster production. So, this is the tapping attachment. This was discussed earlier also. This part looks like shank, this is fitted into the drilling machine spindle and it is rotated. So, this is the tap at the rear end which goes inside the job. So, there is a job fitted into the table and is already a hole has been drilled previously called tap size drill, and then this tap will be now here, which will be gradually pushed in, and this will rotating and then this will be moved in this direction. While going inside, this will produce the thread, that is good, But how to return, how this will come back? For bringing it back, first of all it has to be rotated in the opposite direction, then only this will come, and then immediately this will not return. If you try to bring it back immediately, then the threads will be spoiled. So this one, this tapping attachment is made in two parts. One, this is the one part which is fitted into the spindle, and there is a clutch, and this part is separable by the spring, not exactly separable, but there is a small gap can be created and they are held in position by the spring. Now during return there will be a small gap in between the clutches, and then this will take little time to return, this will return, and then the spring will bring it back, and there will be again clutch joint, and they will rotate simultaneously for bringing back. So this slight gap between the rotation of this one and this one is necessary to bring the tap back, without spoiling the thread. That is the characteristics of tapping attachment. Now this is faster production. Now this production rate can be further enhanced. In this, how this will be done? This is, you see that a tapping attachment. This is a tapping attachment mounted into the spindle, and this is a tap, this is the nut like jobs, okay, nut like jobs, simpler small jobs hole. This will be pushed one by one from the magazine, and the thread will be, this tap will go inside, and when the tap will come out, the particular job will come up and will be accumulated here. So you keep on sending the blank and doing this work. So all these nuts will be accumulated on this bent shank, and because of the centrifugal force this will be thrown out and they will drop out from this spout. So this way you can produce nut like components with internal threads very fast with the tapping attachment. Now production of screw threads by rolling. In respect of thread cutting, so just now we discussed the thread cutting process like machining, okay, that is called thread cutting. Now we are going into thread rolling. What is the difference between these two? Now the difference is, in comparison to or in respect to thread cutting, thread rolling is generally cold working process, but occasionally hot rolling is also done for large threads and stronger materials, but mostly is a cold working process. So thermal damage is much less, provides higher strength to the thread, because there is no cutting action, there is no question of stress concentration due to cutting action, only deformation or shifting of material on the plastic state. So the threads and the threaded component remains strong compared to threads cut by machining. Now thread rolling does not cause material loss. So there is only shifting of material, there is no removal of material like machining. So there is no loss of material. Requires simpler equipments. If it is to be machined in machine tool, then lot of costly equipments will be necessary, but in thread rolling simpler equipments with simple movements the work can be done. Thread rolling, in thread rolling blanks need not be that accurate and finished, because after all the material will be shifted, plastically deformed shifted, so the blanks outer surface need not be that accurate and finished. Thread rolling is applicable for threads of small diameter, short length and fine pitch like screws, bolts, studs and similar things, not for lead screw or press screws, etc. Now thread rolling enables much faster production, is very fast production. All fasteners are manufactured by say large volume and faster rate by rolling. Thread rolling, but thread rolling cannot provide high accuracy. Yes, it cannot provide high accuracy because it is a forming process. Is mostly used for making external threads. Internal threads are also rolled sometime, but very occasionally, very rarely, and say for short length and for soft material and for small threads. Okay, sometime the internal thread can be done by rolling, but mostly it is done by external threads. and it is also thread rolling needs different dies for different threads. Now, one single point tool can cut screw threads of different pitch, different TPI, different diameter, different length, but if you want to do thread rolling, manufacture thread rolling, then a particular TPI, particular form of the thread or particular diameter of the thread, you have to use a particular die. So, large number of dies you have to procure. This is the one limitation of thread rolling, unlike machining. Now, what are the different methods of thread rolling? Thread rolling, dies used, different, these are dies, thread rolling is done by dies. Okay. Now, flat dies or circular dies, there are two kinds of flat dies and circular die. What is the principle? Here you can see the principle, this shows the principle of thread rolling. There is one block or plate which has got grooves, inclined grooves like this, and the other part has got also inclined grooves, and this is the blank, okay, machine blank placed inside, and then this is fixed, okay, and this one is moved tangentially. So, you get the threads produced. These threads, those which were there in the die, they will be reproduced onto the job by deformation, material deformation. Now, this is a say bottom die, this is the bottom die which remains fixed, and this is the top die which moves like this, and is slightly tapered so that it enters gradually and takes the full depth. Now, this kind of circular dies are also there, we shall discuss. Flat dies, when we talk about flat dies, this is a flat die, these are all flat die, can be three types: horizontal, vertical and inclined. Now, this is the example of vertical, this is the example of horizontal, the horizontal movement. This is very common, very convenient and very common. Verticals are also used. So, one die is fixed like this with thread, and this is the blank, and other die will be moved up and down. In case of vertical flat die, there is some advantage. The gravity can be utilized for lubrication purpose and cleaning. So, whatever debris that will be produced will automatically fall under gravity, and the cutting fluids and also will also the lubricants will also fall under gravity. Secondly, the vertical systems always occupy less space. So, space saving is also possible, only operation may be slightly difficult, and it can be inclined also. If you want to derive the benefits of both horizontal and vertical, inclined system is also provided. Now, let us come to circular dies. Circular dies are very common and these are convenient. Okay. You remember, that wherever possible the sliding system should be replaced by rolling or rotating system, because rotary systems are easier to manufacture, design, operate, maintain and all these things, unlike sliding. The lot of wear and tear takes place in sliding action. Now, here you can see the principle. There are two dies. Dies are nothing but two discs having threads, say right hand thread, identical, and both of them are rotated say in the same direction clockwise, and the blank is placed inside. This is a top view and this is front view. This is the die and this is another die, and this is the blank placed on the rest. Now, this will be moved forward. Now, when this will move forward and come into contact, the threads, these threads will be reproduced on the blank gradually, and you get the thread on the job like this. Now, here what are the movements involved? Rotation of these two dies, and the top of that one radial feed. Now, if you can reduce the motion, then it will be more economic and convenient. So, this movement can be reduced by this method. In the second method, there are two dies, but this is very similar to this, but in this case the other one where the threaded portion here the threaded portion is gradually increasing by an Archimedean spiral. and then it becomes straight like circle. So, when this will rotate in this direction in contact, this portion of the thread will gradually penetrate into the job, and then this will continue. So, the whole area will be threaded. Now, after when it comes like the, when it rotates in this direction, now this slot will come in this position and the blank will go into this slot and this will automatically fall down. Now, you put another blank here for the next operation. So, this is improving the production rate. Now, the thread rolling, another process in annular space between dies, between two dies. Here you see that there is one external, is a ring which has got threads inside, okay, to be produced, and this remains fixed, and there is another die or a cylinder which has got external threads, and the space is annular and this is tapered eccentric. Here you see the eccentricity. So, this gap is changing. Now, there is an opening here, through the opening the blanks is dropped here, and now when this rotates, this gradually moves through this annular space constricted and the threads are produced onto that, and there will be an opening, through this opening this will come out. So, this is the faster production. Now, you can see that only this portion is utilized. If so, then this is the die which has got external threads, and this is only a part of the outer die which has got through thread here, and the space is gradually tapering. So, from the blank will be placed, a machine blank will be placed one by one into the space, and because of the rotation this job will roll through the constricted passage and will get the thread, full thread, and then drop out through this force. So, this is a very faster production by dissector. Now, come to grinding, finishing and production of thread. Now, I told you, I remind you again that screw threads are normally finished by grinding, but nowadays threads can be originated by grinding and finished by grinding, and simultaneously originated and cut, there is cutting and finishing. So, machining will be not required at all. Now, here this principle is very simple. Now, you remember that in case of single point chasing, we use a single point tool, the job rotates and the tool travels in this direction. Now, in thread grinding, this cutting tool is replaced by a grinding wheel. This is a single rib which has got a form of 55 degree or say 60 degree, is a large diameter. This will rotate at very high speed, and this will rotate, job will rotate at low speed, and this grinding wheel will be mounted on a grinding attachment, and that will be fitted onto the lathe bed if it is done by attachment lathe, or this can be done straight in thread grinding machine or grinding machine, cylindrical grinding machine or thread grinding machine. Now, if you want to increase the productivity, then this is called multi-ribbed, just like say single long thread milling cutter and short thread milling cutter. The milling cutter is replaced by grinding wheel. Since it is a grinding wheel, the gassing is not required like thread milling. So, this will rotate at high speed and will move slowly in this direction, and this job will rotate slowly. So, this translation and this rotation are synchronized, and you get very high finish in dimension accuracy, form accuracy and surface quality threads. And you can use this technique for small threads as well as very large threads, and different types and forms of threads grinding is applicable. Now, internal threads grinding, yeah, this is also possible for small. Suppose this is the job and their threads have to be finished or cut here. So, what you do? You put one grinding wheel here, ribbed grinding wheel, and you rotate at very high speed, and then this will rotate slowly about axis, and then this will move inside. So, then this way you can produce internal threads, very similar to external threads by multi-rib threads. It can be single ribbed also. Now, centerless grinding. Now, you remember what is centerless grinding? There will be a grinding wheel, this will be the job on a rest, and there will be guide wheel. Okay. This will rotate at high speed, this is the job will rotate slowly because of this roller, okay, the guide wheel, maybe rubber, hard rubber. Now, in this case is a thread rolling, thread grinding by centerless method. This wheel will have, this will be threaded, this wheel will be just like annular threads, not as a helical thread, but annular grooves like. So, this kind of wheel. So, this has got threads. Now, this is a hard rubber without thread. So, when this will rotate about this axis and the job will be in contact, these threads will be reproduced on the job. So, job will be threaded. So, this is called centerless grinding. Now, how it is done? What is the other view? So, this is the grinding wheel, and this is the workpiece, and this is the guide wheel. Okay. Now, so this will rotate and this job will be threaded. Now, if the job is very long and you have to cut long through threads, then the guide wheel has to be placed in an inclined fashion, and this will automatically feed and you will get the thread cutting. So, this is how you can produce the threads. Thank you.